He's got some long hair. I know, this is gonna be great. He's got a nice hat.
That looks like one of those memes. You know what I'm talking about?
Yeah.
What exactly happens? Does that just update this balance property? Like subtract the 5 here and then add it to that account store object? Or some other things happen?
Yeah, it sounds like you, this is a question you asked me earlier.
Yeah. There's a reason why I'm doing this, you guys.
Okay.
That's really interesting because you're basically saying that all of this came out of you supporting a team that's building on Aptos. And you realized that something was needed for this team. You built something for that team. Turns out it basically improved everything on Aptos.
That's right.
It's very cool. That's their rel right there.
That's right. That's
That's their rel right there. Hey everyone, my name is Chris Kim, and today we have Greg. Greg, you want to quickly introduce yourself?
Yeah. Hey, my name's Greg. I'm one of the founding engineers at Aptos Labs and also the head of developer relations.
Yeah, so he's my manager, so I have to look good to him. But yeah, so today here, we're going to do a quick whiteboard session on Aptos Move objects. So Greg, quickly, just briefly explain to us what objects are on Aptos Move.
Of course. So objects on Aptos Move are collections of resources in groups that make logical sense and then has some built-in permissions, ownership, and other features to it that make it really easy for you to manage those collections. So originally at Aptos, we have the idea of resources.
Right.
So you have an account, and then you have one resource for maybe coin store, one resource for maybe your NFTs or whatever it matters. It doesn't really matter. So you'll have a bunch of these resources.
And they get stored in the account, not in these Move modules, right?
That's right. So the way that it works is that it's installed in your account, in your account space, and it's attached to your address. Okay. But like if you have, let's say you want an NFT that has money attached to it, there's no way here without building yourself a custom NFT mechanism for it. So the way that we kind of thought about that for objects is, how do we manage things where they're collected in a group that make logical sense? And then also, how do you do things like composability and other pieces?
Yeah.
So one of the things we started with was NFTs. Thinking about NFTs, a lot of people wanted to do things like in a video game. Like say Legend of Zelda or something, and you got your character Link, and then you get a shield, you get a sword, maybe the shield has a gem in it that makes it stronger, and things like that. When you have a bunch of NFTs separated from each other, it makes it a lot harder because you have to then manage the state between each of them. And then also, let's say you put the gem in the shield, you take the gem out. You now need some customization associated with that.
Right, you need to be able to update the metadata and stuff.
Yeah, but think about if each one is a separate NFT. How do you combine them?
Right, so like this character is currently holding a shield and a sword and some armor, but if they're all just separate entities, then it's hard to like find them and update them individually. That's what you're saying?
Yeah, and so NFTs are a great example for objects to make it simple. So let's say I have my character.
Great drawing.
That's right. Right. Usually for like a game, you'll have like you'll have an inventory with a bunch of different slots.
Yeah.
Okay. So I have my shield. I know my sword.
Really, you call this a sword? All right, bear with it. Okay. This is a sword. Okay, guys.
So my brother always would draw these.
Oh, that's a bit better.
These stick figures.
There we go.
You'd always draw stick figures for everything, and there you go. So, all right. So I have a sword, and the sword can be upgraded. I also have a gem.
Yeah.
No, a gem or something that can upgrade those. Okay.
Okay.
So the character, let's say, is an NFT. So this is my NFT. I want to put a shield in the NFT. What do I do?
You have to equip it.
Yeah.
Somehow.
So equip it.
But these are all each NFTs, right?
They're all each NFTs.
is there some kind of way to link them? Well, without objects, maybe.
So without objects, like you have to probably put some custom logic in it.
Yeah.
And you probably have to burn the shield or store it somewhere at some locker.
Oh, that's a mess.
Yeah, it's a mess, right?
Yeah.
So why bother with that?
Right.
You can sit and say, this is an object. Okay?
Mhm.
An object has two parts. Well, there's all the resources. So these are your resources that are associated with the object. And then here's the object metadata, which we call object core. So object core has an owner, is transferable, and a couple other things.
And these are all attributes that exist in all objects.
All objects.
Okay.
So, all right, so the reason for this is I basically have an object here that has a resource that describes what an object is, and the properties of the object, and then any arbitrary resource associated with it.
Oh, so you can add other like resources and structs inside of here.
That's right. Because the object has an address. So it's in addressable storage. That addressable storage works exactly the same as the account that I was talking about earlier.
Uh-huh.
So an object is essentially an account, but with some extra information that's associated with it.
I see.
And there's some other distinctions, but I'm not gonna get into that.
Like for example, the object can't sign transactions. Or something.
Yeah, by default, it can't sign transactions.
Oh, it can.
It can't.
It can't. Okay.
You actually, because of the stateless account grade, you can sign as any address. So if you have a key that maps to that address, you can sign as that.
Oh, okay.
But you're right, like you can't come with an arbitrary one for it because it's like to the 256 possibility of getting a conflict, right?
Yeah.
It's very hard to have a conflict there. So now that I have the object core and I have the resources associated with it,
Yeah.
I can think about here as this owner. So I have an owner associated with the resource, and then down here we'll actually have the NFT data, which we actually call, I think, token object, or
Okay.
I think it's called token. Okay.
Is this a resource or a struct?
So that's a great question.
Mm-hmm.
So a struct is a resource
Right.
when it is stored at an address.
Right. Which has the key attribute.
The
right?
key attribute, yeah. So this would be token has key, and then when it's stored at this address, it's a resource.
Gotcha.
This is actually a resource as well, the object core.
But this comes to all NP objects by default.
Yes.
Okay.
And you can't create it yourself. You have to only create it from the contract that creates objects.
Yeah.
So if you create an object, it'll create an object core.
Okay.
If it's not an object, it can't. You can't add object core.
So you know how in Move you can call the function create_object,
Yeah.
right? And that creates an empty object, right?
Mm-hmm.
When that empty object is created, is this also created by default, or
Yes.
Okay.
So
And these properties, do they get set to some default values, or do you have to set them manually at the initialization stage?
it's a great question.
Mm.
So they do have default values. So by default, like is transfer is true.
Okay.
Okay. The owner is set to the person who created it. So
Ah.
there are, I think, 3 different methods for creating an object. There's a named object,
Yeah.
which takes in a signer of the owning address
Yep.
plus a hash,
Yes.
or plus a name to hash. Then there's the second thing is having a derived object. So you basically use a address and then randomly choose one, or basically randomly generate some extra information in it that creates the object.
Okay.
And then the third one, which is a particularly specific case, is like you can derive an object from another object,
Oh.
right? But it's once again, it's some domain separation,
Okay.
an address, and some hashing to create another address.
Gotcha.
Yeah.
Cool.
But yeah, they're all defaulted. Usually the owner is the person who created it. But you can create objects for other people that haven't necessarily signed the transaction.
Got it. I might be sidelining a bit too much here, but just an extra question, a follow-up question here. if I want to modify these default values,
Yeah.
can I only do that at the initialization stage when we have the constructor ref, or can we modify them like whenever?
That's a good question. So, you mentioned constructor ref, which I
Yeah.
didn't say anything
Right.
about.
Well, I have some prior information, so
Okay.
prior
So,
knowledge.
the great thing about objects is you define the behavior at the beginning.
Yes.
So you define what it can and cannot do at the beginning. And that's the purpose of being at that. So you're transparent what you can do with it.
Yeah.
Especially like, I'll go back to the NFT example, right? You don't want people to change things underneath you because they can. So what you have are 3 different types of refs, which are in the capability model.
Yes.
So basically you have a resource that you can store somewhere else
Mhm.
that allows you to do things. So there are 4 refs: constructor, transfer, delete, extend, and actually there's technically one more, which is linear transfer.
Oh, I wasn't aware of that one.
You wouldn't have known unless you tried to use the transfer.
Okay.
Okay, so these 5 are used for modifying an object afterwards.
Afterwards. Okay.
These 4 are.
These one.
This one is only live in the transaction that you created the object.
I see.
So the constructor ref specifically has the word, it does not have store, but it has key, it has drop. Store but not drop.
Mm.
So that, drop but not store.
Okay.
So it has to be dropped at the end of the transaction,
Got it.
but you can't store it anywhere. So that means you can't use this for any other time.
I see.
So if you want to create custom logic around that on the creation of an object, you have to use the constructor ref.
Got it.
And that's why the constructor ref actually is used to create all these other ones.
Mm.
Except for this one. This one's actually special. So
I see.
transfer, delete, and extend
Mm.
are all created from a constructor ref to say, at the creation of this object, I want to control how it's transferred, how it's deleted, or how it's extended. If you do not create it at the time of construction, you cannot modify that later. So keep that in mind. If you don't put a delete ref, you cannot delete the object. You don't put the extend ref, which the extend ref is used to sign for transactions for the account. You can no longer modify the resources
Mhm.
in the object, or any other time that you need to use a signer for this address, you can't get it.
I see. So without the extend ref, if I want to add like another resource to this object, I can't do that.
Nope.
Oh, okay. So that's like pretty important. the
Yeah.
Extend ref.
And most of the times when I create a contract that I want to be able to extend or change an object later, the extend ref. The delete ref, the most important part is you have to think to yourself, am I going to delete this object?
Mm.
Because when you delete it, you get back actually gas. So there's a storage refund.
Oh.
If you don't call delete ref, if you don't call delete, even if you delete all these other resources in here, because this one doesn't get deleted, and these all inherit what we call a single storage slot,
I see.
if you don't remove everything in that storage slot, it stays around. If it stays around, you don't get your storage refund.
I see. And the storage fee, where do you have to send that somewhere, or is it just like locked within your account? How does that work?
So I don't remember the exact details, but basically what happens is when you try to create something that creates a storage slot, so an object in a normal account is just a resource. So what happens is we take a deposit for that storage slot because it costs like a non-negligible amount of storage, and then we put that into like a counter of keeping track of the storage slots and how you can get the money back from it.
Got
So it
it.
basically pulls it out of the pool of the network and puts it into the
Okay. That makes sense.
storage refund pool, I think.
Yeah, that makes sense because on-chain storage is expensive. You
Yeah.
don't want to make it
Yeah.
free.
But there's no rent. So there's no rent on Aptos. So it's just a deposit at the beginning.
Just a deposit.
And then you can get it back later if you free it. So if you don't get rid of all this stuff, you don't get the money back.
I see. So as a developer, if this object doesn't necessarily have to be permanent, it's smart to have the delete ref and be responsible about it and make sure the module that you design handles that properly so that you get the fees back.
Yeah, and I would always suggest for people who want something that can get removed to have this delete ref.
Mm.
If you don't expect it to get removed, like maybe you have a soul-bound like object that is keeping track of your game score,
Yeah.
maybe you don't want to be able to delete that.
Sure.
right? Then you don't put it in there. Otherwise, we keep it. The cost for storing this is negligible in comparison to the ability for you to get the money back at the end.
Got it.
Yeah.
Okay. Cool.
And you can also like just add this, and like if you have your contract is mutable later,
Mm.
you don't even need to start with anything you do with the delete ref. You just store it, and you're like, oh, later I want to be able to delete it. I can create the function to do it.
Okay.
So it's good to have.
If I have the extend ref, because you said if I have this, I can modify the object.
Mhm.
Can I use this to add delete ref or transfer ref later on?
No,
No.
because
So you need
their
that.
function only uses the constructor ref.
Got it.
Yeah,
So it really is like the initial, you have to do it at the initialization stage
that's right.
and define what this object is going to be used for.
Yeah.
Makes sense.
Since I never got back to the original example of objects.
Sorry, I went sidetracked so hard.
Transfer ref. So what a transfer ref is, you can control the ability to transfer.
Yeah.
So as you might know, like what I mentioned earlier, there's the owner.
Mm-hmm.
The owner is initially immutable, so I can change it to a different person. So
Yes.
I own the object or the shield or whatever, and then I can say, you want to own it, okay, I can transfer it to you. And you can the owner has the ability to transfer it at any time by default. But let's say you want to control that. You have a game, and if someone transfers your game data to a different owner, it screws everything up.
Yeah.
So what you do is you create a transfer ref.
Mm.
You create the transfer ref, and you can turn off the ability to transfer. So this transfer ref can actually change this value
Oh.
if it's transferable.
Okay.
And then, so if you turn it off, you can do another thing with the transfer ref, which you can create what we call the linear transfer ref,
Mm.
which, you know, I really wish that math had better names for things. Linear is, like, I was super confused when I first saw linear transfer ref.
Yeah.
What does that mean? What does that mean?
Yeah,
Because, like, I forgot that linear also means one time only.
Oh.
So in math,
and
and
not
like,
linear. Okay.
We talk about, like, we actually talk about other places in the docs and stuff about that. Move is about linear objects
Yeah.
or linear resources and the ability to have one-time use resources. So linear means it's one time and one time use only.
I see.
So that's why it's called linear transfer ref, because you can use the linear transfer ref to transfer the object once.
Even if is transfer set to false.
That's right.
Got it.
So what you can do actually, you can say you create the transfer ref.
Mm-hmm.
You can create a linear transfer ref and store it somewhere else,
Okay.
and then transfer and use that later to transfer the object.
So when you say you transfer the object, that means this property right here, the owner property changes to a different address.
Yeah, so this changes a different address. The beauty actually of the objects, as you mentioned, the change of the address is that there is no actual change in state in the whole world here. Because before, with resources, let's say I wanted to transfer a resource from me to you.
Yeah.
I have to destroy this storage on in my account and then recreate in your account,
Oh, really?
which is significantly more computationally expensive and significantly more storage expensive,
Right.
right? So instead,
So it wasn't actually being transferred, it was just deleting it and then creating a new one, like
Yeah.
a duplicate of it.
yeah, and you know that when you think about it, you're like, oh, that's simple enough. But then
Yeah, but so-
you realize that actually causes a lot more cycles,
Of course.
right? Of things. So the easy thing here with the objects is because of the built-in ownership, you just change the address. So you change the address. It's a single. It's like 256 bits,
Uh-huh.
and there's super low cost. But you get the
Interesting.
powerfulness of being able to change the ownership like that.
That's actually really interesting. So it's no longer directly tied and stored inside of an account. Is this object just lives on some on-chain storage and has this property called owner that defines who owns this object. And whenever you want to transfer this, it's not actually being moved around or being deleted and duplicated. You're just changing that owner property.
That's right.
And the transfer works.
Yeah, and that's
Smart.
that's also one of the reasons why we can keep gas fees so low for things like NFT transfers.
Yeah.
Because NFT transfers are so simple. You change a single field.
Huh.
Okay? All right, so we've gone through all this about objects, constructors, transfer refs, delete refs, extend refs. I'm going to erase this.
Yeah, go ahead.
Okay. So now we're going to get back to our little guy here, which I'm going to erase.
Nice.
All right. So let's say we have our guy here. Since
What happened to this guy's face?
He's a little disappointed. He's a little disappointed. He's a little disappointed.
Make him happy. There we go. Big smiley face.
There we go.
I like it.
So let's say I want to have a shield, okay?
Yeah.
And the shield has a couple slots, 4 slots in it. And then I have a bunch of gems, let's see. All right, I have a couple gems that I can put in. All right, this is not too bad.
Yep, it's all right. It's passable. This looks like an acorn, by the way. But I'll say it's a gem.
It's a poor. Usually there's like a poor man's version of gems in these games. So,
Sure.
All right, so man, this is an object.
Okay.
Right. This is an object. This is an object, and this is an object.
Just a quick clarification. So NFTs are just objects on
Yep.
Aptos. Okay.
And the original name for NFTs on Aptos was token objects, which we renamed to digital assets because it got really confusing because it was kind of an NFT standard, but it can be used for fungible tokens and semi-fungible tokens. So we named it to digital assets, which is really what it kind of maps to.
I see.
Right, digital assets that, and then you can have the ability to have them be non-fungible.
Okay. But now it's an object and there's a new standard for it?
No, it's called token objects, but
okay.
the standard and the docs somewhere says token objects,
Token object.
but it's called digital assets.
Digital asset.
Yeah.
Got it. Okay, I may have some follow-up questions about that, but
Okay.
let's go to this first.
So these are all objects. All right, so looking at what we had before about the object,
Yep.
the simplest thing we can have here is, instead of me having to move the data around, I want to just change the owners. So maybe I want to equip a diamond here and a gem here. So I can set the owner to be this object, right?
Now that's really cool because usually when you think, oh, this object is owned by someone, you would think only accounts can own it. But you're saying that objects can own objects because they all have addresses.
Because any address can be owned by another address. So now I have these gems are in the shield.
Yes.
Okay. The great thing here is, let's say I want to sell my shield to you.
Okay.
I just transfer the ownership of the shield to you. You get the gems with it because they're owned by the shield. So that way you actually have the ability to make something be more valuable while controlling the ownership and being really easy for the composability side.
Yeah, that makes sense.
Yeah, you're learning a lot today, huh?
I am learning a lot today.
Okay. So then all I do is I change this object to be owned by the person. And that's it.
And if I want to sell my character, I can sell
I can sell my character,
and
I can sell the shield, I can sell the gem, whatever piece you want, it will go in like a collection.
Wow.
Yeah.
This can literally create the next generation MMORPG. It could be my side hustle. Make my own character, like level 100 with legendary sword. I sell that.
You should make RuneScape.
Maybe.
Yeah. I might be dating myself.
Yeah, RuneScape is a bit before my time.
I was in middle school.
Alright, that shows his age. But.
Yeah. But it was all the thing back then. But yeah, so that's how it applies here, right? So NFTs are a good example because you can understand why ownership matters.
Yeah.
And why it really makes composability in that part really nice.
Mm.
So I'm gonna erase it now. There are a couple other examples of how objects become really powerful.
Yeah.
And I can go through NFTs some more, but I'm gonna skip that because we're done with that. We're gonna talk about fungible assets.
Yes, that was one of the questions I wanted to ask.
Yeah, so fungible assets is our standard for fungible tokens on Aptos. Think about ERC20 style tokens, that's us. So the way that it works is there is a object, which we call the metadata object. This object has the object's core in it, as mentioned before, and then some metadata.
Resource.
Yeah, which is a resource. Generally, wow, I can't speak. Generally, with these resources, because they're all resources, I just box them and they're no longer separated out into these two groups when I draw these objects.
Okay.
Just for future reference, because there's a lot of boxes.
Yeah. Yeah.
Right?
I hear you.
So the metadata will have things like the URL of image, name, number of decimals of the asset.
Are these optional or mandatory properties?
They're all mandatory.
They're all mandatory.
I mean, you can put an empty string in the
Yeah.
URL, put an empty string in the name.
Sure.
But, well, actually, the name maybe not, but
Okay.
I can't remember. I think it might check.
Mm.
Number of decimals is required to be within 0 to, there's some number.
Okay.
Like some reasonable number is like 8 or something.
Okay.
Because with, I think it's on a 64-bit unsigned int, there's only so many digits you can
Right.
have. The funny story is when we first launched it, it had 255,
Oh, really?
which is too large for the space. And then I put the check.
Has anyone made an asset with like
yeah, they did.
100 decimals?
They did it for the coins, the coin thing. Okay, so this metadata keeps track of it. But then what you have on each user, so in order to hold it, is you have what we call a store. So store object, which is owned by an account. Technically an object.
Right. But that metadata object, is that owned by the creator of that
Yep.
fungible asset? Got it.
Okay. So we have a store object. Store object has, a count, or I think we call it balance. I think that's pretty much it. I'm trying to,
I think so too.
I think there's some information about like transferableness and other things that are associated with that. So, because there's a way to freeze the assets.
Right.
So now we have a balance and some other stuff. The only other thing that isn't here is there's also metadata object. So this here points at the metadata object.
What do you mean by point?
It's literally, it's the address. So it's the address of the,
Oh, it's the address of the metadata object. Got it.
so anytime we talk about pointing, there's no such thing as pointers.
Right.
So it's really just an address that is the address of the thing that we're looking at the relationship.
Mm.
So this is the type of asset that's in the store.
Right. So that's how you know what asset is being stored in the store object.
That's right. So then I can have actually multiple assets. I have one asset per store, and then I can have multiple
Right.
different
So
store
there will be
objects.
multiple of these store objects within that is owned by an account or an object to specify that this account holds multiple assets.
Yep. And that's really easy now. So I have ownership, I have whether I can transfer the object, not just the transfer of the balance, and then whether I can transfer the balance is inside this object.
I see. So what happens if this account, let's say this store object holds 10 APT, well, because APT is not fungible asset. I'm assuming that APT is stored in this way now, right?
Yeah.
Okay, so let's say this account holds 10 APT, and I send 5 APT to somewhere else. What exactly happens? Does that just update this balance property? Like subtract the 5 here and then add it to that account store object? Or some other things happen?
Yeah, it sounds like you, this is a question you asked me earlier.
Yeah. There's a reason why I'm doing this, you guys.
Okay. So what happens is there's several steps. So one, withdraw from store. So I'll take from the store by, let's say -5, and then I have a 5 fungible asset here.
Okay.
Okay. Then the second step is I deposit into other store. So then what I'll do is I'll go to another object, another store, and I'll transfer from there and change the balance +5.
Yes.
So this actually creates a resource, a struct, or a hot potato resource, as we call them.
Right.
And this has to be stored in another store by the end of the transaction. If you don't, then the compiler and the runtime will say, hey, you forgot to put this somewhere, this is an invalid transaction, and abort.
Mm. And what is inside of this hot potato struct? Just the balance? And does it also have the metadata?
Yep, so
address?
it's exactly the same as this. It's the metadata address and the balance.
The balance.
So
So whatever is inside of the store object.
it's pretty much the same, except it doesn't have the transferable
I see.
part, right? There are some other parts that come with it, and I probably can't remember, that are more akin to about the store part than limit transfer.
Okay, so it's just like a temporary struct, not an object, that contains the balance and the metadata address of the fungible asset, and it's temporary. It has to be stored in some kind of a stored object before that transaction ends, and that's how it gets transferred.
Yep, and that means that at any time, we know where all of the fungible assets are. They are tracked in stores, and you can easily index them.
Oh.
Yeah. The other thing is, this is held by the actual compiler, that it prevents it from being stored anywhere else.
Really? That's
And the runtime, actually. So that way, it's really just made sure that you can't lose track of them, and that they can't be double spent, they can't be burnt, they're accounted for.
amazing. Got it. Interesting. So was fungible asset one of the reasons why you guys started thinking about objects? Or what was like the initial, wow, we need something like an object on Aptos Move?
So there are a couple things. Is one, actually, we originally came up for the NFT, for the digital asset standard. And the reason we were working with this Korean team was Metapixel.
Okay.
Once upon a time. I was about to say Metaplex. Metapixel was a subsidiary of NPixel in Korea. They were building a game, and the game was going to be fully on chain. And they were talking about how could they build out this expensive stuff. And we really worked with them closely to build and see that our current system did not scale for their needs, because you had to do all this extra stuff around keeping track of the objects, the costs associated with moving lots of stuff around. Just didn't scale quite the way we wanted it to.
Yeah.
So we built the object standard to help that, and then also we were built it to help the coin of fungible asset, because the original standard was a little bit harder to track where the things were, and then also this made for a lot easier way to keep track of things like the metadata associated with it. So the metadata was a lot easier to find, the address on chain of the image, as well as it also helped you with the ability to keep track of, when you start trying to do some DeFi, when you're using the original coin standard, you have to use generic types. And it's great at first, until you get really complicated, and then it ends up being a lot harder.
Right.
And actually, that's been a lot of the things that people like come and complain to me about. Like, they're like, hey, like, it's really hard to work with the coin standard for the purposes of some DEX or some complicated vault or something associated. And then they learn, hey, but this is a lot easier because I can keep track of the address of this metadata object, which can store easily, you can keep it flexible, and it's much easier that way.
That's really interesting, because you're basically saying that all of this came out of you supporting a team that's building on Aptos, and you realized that something was needed for this team, you built something for that team, turns out it basically improved everything on Aptos.
That's right.
It's very cool. That's their rel right there.
That's right. That's
their rel right there.
Yeah, I mean, it was not like, it's nothing without the community and the ecosystem in order to build these things, because we can sit in a bubble and we can be like, hey, these things make sense, and we can build and build and build.
Yeah.
But if we don't get feedback from people about what we want to build and how it affects them, then it isn't useful. That's why we also built a dispatchable fungible asset store on top of this. It's really not that hard to explain, but it basically just does dynamic dispatch. So for people who don't know dynamic dispatch, static dispatch means you basically know when everything's gonna happen at compile time.
Yeah.
Dynamic dispatch means you don't know what you're gonna call at runtime. You figure it out at runtime.
Okay.
So you're not going to know at compile time. You're going to know at runtime when it will happen.
Okay.
What will happen. Move was originally designed to be static dispatch only, and the reason being to prevent bugs that come with dynamic dispatch. Because you don't know what you're going to run, you don't know if it's going to work, and that is kind of messy. But that's why we came up with this dispatchable functional asset, sort of fill in a gap of where we want it to be easy enough to work with, but held within certain guardrails. So basically what happens is instead of doing a transfer, you first end up calling the dispatch function, which then runs custom logic based on whoever created the asset. And then that custom logic will then be followed up by the normal transfer logic.
I see. So you can add some functionality to a normal transfer.
Yeah, and technically it's not on transfer, it's technically on the withdraw step and the deposit step. You do two separate dispatches. So, and for whenever you want to do something on a transfer, you can do it on one or the other, because you can keep in mind you have to deposit somewhere, you have to withdraw it somewhere.
Yes.
So that's where you can kind of do things on a transfer, you do it on one or the other. Depends on your use case.
Could you give us a couple of examples of what that custom logic could be?
Yeah, so you can have a, let's say, circle, they have to abide by sanctions, right? Or you have to freeze accounts or whatever associated with it, which in order to abide by certain regulations. So what they have is an allow list, or a block list of people that they freeze. So then when you come through here, you can block whoever's going to be transferring to make sure that they can't transfer it. Say it's North Korea or whatever, like you're going to be blocked. And the way that makes it really simple is you just add addresses or whatever to this list in their custom logic, versus going through some other parts where you have to keep track of it all.
Yeah, that's really nice, because you're basically doing that check during the transaction, and you don't have to create like a function where you're doing a bunch of asserts outside of the transaction, and then once everything looks good, then you send the transfer. So that's really nice.
Things like that. You can do taxes on meme coins. That was a common thing that people always asked for.
Commissions, I assume.
Commissions, yeah. They call it taxes.
Oh, they call it taxes. Oh, same thing. Okay.
And basically, every time you transfer, you take some piece
Right.
out of it. You transfer to somebody else, you take some piece out of it. Very common for meme coins, especially because they're really about incentivizing trading, but they want to still get some return out of it.
Yeah.
It's very confusing to me, but.
I mean, it's a great way to monetize your app, right?
Yeah.
Taking some commissions per transaction. It's like a high volume kind of application.
Yeah.
Very cool. Wow, we covered a lot today. Honestly, like you really covered all of the things that I was wondering about objects. Like this object core and the resource. This was a bit confusing for me.
Yeah.
But you clearly have explained that.
Well, there's one thing I wanted to mention about that. So technically, an object has nothing to deal with this box around it, but this is called an object resource group. And this is going to be useful for you because you probably don't know what I'm talking about.
I did see it in one of those code examples. And
So-
it was gibberish to me. So please do explain.
Yeah, I think we need to write a better doc on it. 'Cause I also didn't know until after I spent a lot of time to figure it out. So a resource group is how we store all these resources together into one storage slot.
One storage slot.
So remember how I mentioned before, storage slot is what you pay for
Yes.
in gas. So normally in an account, each resource is a storage slot. Okay, so that means I have 100 resources, I pay for 100 storage slots.
Yes.
It get kind of costly. It's actually the most expensive part of a gas transaction
Really?
on Aptos. But now let's say you put those 20 resources in an object, in a resource group. So now you have 21 resources that are stored in a B tree at that storage slot, and stores it there. You can actually create resource groups for other things. I don't suggest it. It gets really confusing.
Okay.
But sticking with the object resource group, whenever you want to create a resource that goes in here, and you want it to be tied to the object, I would add the object resource group annotation. And that means every time you store it, it'll be in the same slot, which will cut down on cost from that perspective of storage. But there's a second kind of like obscure thing that's associated with it. Let's say there's a resource.
Yeah.
Okay. And you want to know who owns the object whenever you interact with it in the right set, the end state of the transaction. If it's in this resource group, all the resources that are in the resource group will come out at the end of the transaction if anything changes in here. Because write sets come out of the on-chain data, and then I know this is getting deep.
No, I like it. Go deep.
The write sets are based on storage slots.
Okay.
So this whole slot will be listed. So let's say I change the name of the token in the NFT data. I change the name of the token. It will also print out the owner and is it transferable and everything. So now I can say, oh, I see something where the name of the token was changed. I can also see who owns the NFT. Or I can also see the other metadata associated with the NFT. Right? Like there's a token here, but maybe there's another one that says part of a collection. I want to know all NFTs that got modified in the collection. Well, when the name changes in this one, I can see the collections associated with it. Helps with indexing.
I see. Okay, so it definitely helps with like it just returns everything. So it helps with.
And there's a little bit of a trade-off in cost. I don't have a good explanation of when to do it, but my main explanation would be if you have an object, you should put it in the object resource group.
All right. Well, I think we covered a lot today. We covered objects, right, and what's inside of an object, like the object core and the resources that you can store in there, and also other objects. We also talked about the history of objects, how it came to be. They were working with this Korean team that was building on Aptos, found out that they needed something, and they built this object thing, and turns out it just improved everything on Aptos.
You should check out their game, by the way.
Oh yeah.
Supervillain Labs.
Supervillain Labs?
Yeah, they have a mobile game.
Oh, what's it called? Is it called
Supervillain something?
Okay.
I can't remember. But it's basically an idle RPG game.
Ooh, all right, I'll have to check that out then.
Yeah.
Cool. So working with that team basically made this object model and it improved everything. That's why the fungible asset standard came to be, and it just made holding assets, indexing assets much easier on Aptos. So I think that's a great example of DevRel, working with teams and finding out issues about the protocol and improving upon it. And it's just really interesting to see that that's what happened here.
Yeah, and it really drove, fungible asset is completely used for everything now. Coin is completely gone.
Yeah, and basically made storage on Aptos more flexible, more composable. And now you can build more stuff on Aptos, I feel like.
That's right.
Before there was a lot of limitations, more rigid in terms of storage, which is not common on blockchains usually.
We're actually, so I think a lot of the things for the way that we build stuff is about making it flexible for you to do things in different ways to optimize or choose the way that you want to do.
Yeah.
So we went over the object model here, and I didn't talk about the account model, which I probably should have to talk about.
And that's another video. That's for another video.
But like Ethereum uses an account model.
Right.
This is a way that the account model actually fits in while still using objects, which allows you to program in two different ways.
Yeah.
Depending on your use case.
Yeah.
And that makes it really easy to adapt it to whatever application you want.
Yeah, and I think this is what makes Aptos unique in that this allows you to build applications that are just not possible on other blockchains. Cool. Well, that being said, I think we're going to end this video here. Thank you so much for watching this long video session. I know it's a lot, but I hope you found this helpful. And let us know in the comments if you like this, and we'll do more of this. And Greg lives in New York. I live in California. And so, I don't know, if you guys say you like this, maybe they'll sponsor me to fly me out to New York and do more of this. just remotely?
Just remotely. Yeah, we can do it remotely.
Oh man. Guys, just comment, fly Chris to New York. Then they'll pay for my flights and everything.
Yeah. Make sure to check out, we will get you to New York for the Aptos experience.
Yeah,
this
right.
experience is in October.
It's in October. Yes, that's right. So I'll be flying to New York anyways. So maybe we'll shoot more then. But yeah, thank you so much for watching, and I guess I'll see you in the next one.
Bye guys.
Bye guys. Bye.